This conference will now be recorded.
So once again, good morning everyone. So guys, last class we discussed data engineering, introduction to data engineering. We discussed, guys, recordings I will upload in the drive. So in the Google Drive I will upload and I will share, guys. So consider here. So for suppose this is the one I share it to you. I will share this drive to you. So after you register the course, I will share the drive to you. Now how to open that drive? Okay, go to your Gmail. So go to your Gmail. So I provided access to this user. I provided access to this user. So when you log in with your user, okay, when you log in, go to here, Google Drive. Click Google Drive. Here you can see left side panel. Here you can see shared with me. Select this one. Here, this is the drive. Okay, I provided to this person. This is the drive. Here you can see in your Google Drive, there will be a shared with me folder. There you can see this one. So here you can see yesterday recording as well as yesterday notes. So whatever the screenshots, everything I'm going to mention here in the notes. You can go through this one. Okay, so some people are already registered for the course. I share the drive to them. Okay, if I miss anyone, guys, please message me this one, WhatsApp message. Okay, WhatsApp message for drive access. So after the session I will provide it, guys. That is one thing. Now, so coming to, so last class we discussed what is a data. So data, where we are going to store the data, where collection of raw facts, a database where we are going to store the data. So we discussed a database versus a data warehouse versus a data lake versus a data lake house. So database mainly transactional data, small amount of data. A data warehouse, we can maintain the historical data in the structured manner. A data lake is a distributed file system. So to store the big data, so we can use this one. And a data lake house, which is having both data lake and data warehouse features are present in the data lake house. Example, Delta Lake we discussed. And we discussed what is a big data. So big data, huge amount of data, mainly three V's: volume, velocity, and variety point of view. And to handle this one, so we have a cloud. So there is a cloud computing. Through internet, we can access the cloud provider services in the pay as you go model. How much you are using the cloud services, you have to pay for it. And then we discussed Azure Data Engineering Services. Azure Data Engineering Services. So here, as part of this one, so here I said we are having a Azure storage account to store the huge amount of data, big data. So Azure provided a service called storage account. So in the cloud, so there are multiple services are there. Among all, one of the service is the storage account where we can maintain the data. As I said, data lake is a distributed file system. So distributed means multiple systems are required. So in the cloud, it is going to take in care everything. Just you can use the service. So Databricks, which is a Spark engine. So today we'll start this one. And data factory, cloud ETL. Okay, so here last class I told you this one. One second. So here As part of this one, I'm going to maintain the lake. So whatever the multiple systems using data factory, I can connect it to all the sources and ingest the data into the ADLS data lake storage, which is in the cloud Azure. Okay, so on top of this one, we are having a data bricks to process the data, data factory to ingest the data, SQL server. So if you want to maintain any data warehousing on top of it, we can go for SQL server. There, Power BI team reporting generated. So instead of maintaining individual, okay, these are all integrated in the Synapse. Okay, Synapse. This is the one more service. Now, as I said in the last class, these three are integrated with the Synapse. And one more keyword, logic apps. And this is the Microsoft Fabric, guys. Okay, Microsoft rigorously implementing the features in the micro Fabric, but still it is many people are not at productionalized, guys. To use the Fabric, so this is the contains Synapse plus Power BI. Okay, so I will tell you Microsoft Fabric also, and end-to-end project implementation. Two projects I will implement, and I will provide the interview questions, resume preparation, mock interviews. This is the course content which I discussed in the last session, guys. Now, so today we are going to discuss. Okay, so here we are going to discuss, one is what is a big data challenges. So what are the challenges of big data? Why traditional databases does not handle the big data? Okay, how do comma cloud environments overcome big data challenges? And so today we'll start with Databricks also. So these are all the things we will discuss today. Because today somewhat theoretical, so next class onwards are completely practical. So plan accordingly. So, now, so here in the last session, I started recording, right? Okay. Now, here in the last session, I said we have a big data which is having a three characteristics: a volume point of view, a velocity point of view, and variety point of view. So mainly it is having a huge amount of data. If the data is huge, generally what are the challenges we have? One is how to store the data. Another one is how to process the data. Guys, in the last class, if you remember, in the storage related, I said a database, okay, databases, okay, which is nothing but RDBMS. I said we can maintain the data here, okay, Oracle, SQL Server, Teradata, okay. So like multiple RDBMS systems are there. So here what happened is those are all not supported the big data. So those are all not supported big data. To overcome big data, we have a Hadoop and another cloud came into picture. So why is it so? Okay. So before going to this one, let me understand one more thing about scaling, vertical scaling and horizontal scaling. Vertical scaling and horizontal scaling. So here, guys, consider I'm having. So consider I'm having a system. So here I'm having a laptop. Consider the system capacity it 4 GB RAM, 1 TB hard disk. Okay. So here a front end applications data it is inserting. Okay, so 4 applications of data we are inserting here. 4 applications data. Okay, now the system performance is good. Okay, the system performance is good. So right now 4 applications. Now I want to add 3 more applications. I want to add 3 more applications. The performance is not good. So what I'm going to do is I'm going to increase the system configuration. I'm going to increase the system configuration from 4 GB to 8 GB. So here 2 TB, here 2 TB, and here 7 applications of data. It is working fine. So I increase the system capacity. Now I want to insert 2 more applications. I want to insert 2 more applications of data. The existed system capacity is not supported. So again, I'm going to increase the system capacity. So here in this one, here vertical scaling, the same system capacity we are increasing as per the requirement. Okay, as per the requirement, we can increase the same system capacity as per the requirement. So here up to certain level only, we can change the system configuration. If you remember when you purchasing the laptop, okay, when you purchasing the laptop, they said that, so laptop related, so it is 8 GB RAM. Okay, you can extend up to 64 GB. So means as per the requirement, we can increase the configuration. Okay, so that is in the vertical scaling, same system we can increase. Similar way, we have a one more thing, horizontal scaling. Consider I am having a system. Okay, consider I am having a system. In this system, I am having 4 GB RAM, 1 TB data, 4 applications of data, which is working fine. Which is working fine. Now I want to insert 3 more applications. So here, guys, here in the vertical scaling we are changing, but here what happened is we are adding one more system. Here we are adding one more system. So which is also 4 GB RAM. Okay, 1 TB data. Here we can access 3 applications. Guys, here it should not be a same. It can be any different also. Okay. Now, so here these two systems are connected over the network. Through internet, these two systems are connected so that data exchange will be happen between these systems. So that exchange will be happen these systems. Now I want to add a few more applications. So I can add one more system data. I can add one more systems data. Here, consider it can be okay 4 GB, 500 GB hard disk. Okay, so 2 applications data I'm keeping. So here, as per the requirement, we can increase the multiple nodes. Okay, multiple systems. Guys, these are all connected over a network. Now, this collection of systems, we can call it as a clusters. So here we can call it as a cluster. Now, cluster contains collection of systems connected over the network. Generally, this one we can call it as a system, guys. If the system is inside a cluster, we can call it as a node. We can call it as a node. Now, this one I can say it as 3 node cluster. Okay, I can say it as a 3 nodes cluster. Okay, so here, guys, when you are inserting the data into this one, okay, it looks like a single one, but the data will be distributed among the systems. The data will be distributed among the systems. So here it is a horizontal scaling. Here it is a horizontal scaling. Okay, now one second. Okay, now here what happened, guys, All traditional databases are supports a horizontal scaling, but there is a limitation in the number of nodes. Limitation in number of nodes. Okay. So here guys, if the data is increasing, I can add one more node. The data is increasing, I can add one more node. But here, traditional databases, okay, having, so these are traditional databases having a limitation in the number of nodes. Okay, Oracle 128, SQL Server 256, Teradata 512. Like number of nodes are limited. Okay, so that's why traditional databases are does not support the big data, because in the big data huge amount of data it is there. Okay, so the data is continuously increasing. It doesn't support the traditional databases because of the limitation in the number of nodes. Okay, and one more thing is how to process the data. So processing related also. Okay, so here we have to understand one thing is non-distributed data processing. Another one is distributed data processing. Non-distributed data processing and distributed data processing. Okay, so here, so consider I am having a data, okay, which is a file, accounts.txt. So which is a 300 MB. So if it is a non-distributed data, if it is a non-distributed data, non-distributed, okay, if it is a non-distributed, the entire data will be in one of the system. The entire data will be in one of the system. Consider personal laptop. Okay, for suppose if you are want to access the data, okay, for suppose if you want to access the data, for suppose if I want to process the data, so for suppose I want to do count operation. Okay, I want to do count operation. So consider the processing speed is 1 MB per second. 1 MB per second. So 200 total it will take 300 seconds to process the data. Total 300 seconds to process the data. Okay. So here in the non-distributed, entire thing will be in the one node only. One node only. Now the same thing if it is a distributed file system. The same thing if it is a distributed file system. File system. So I am having a multiple nodes, horizontal scaling. I am having a multiple nodes. All are connected over the network. So all are connected over the network. So here through network I can access everything. Here I can access. Now here what happened is all are connected over the network. Okay. Now for suppose I am having a data like this. I am having a data like this. Okay, so this data will be when you are inserted data into this one. So when you are loading the data into here, so whatever the data will be divided into the blocks. Whatever the data will be divided into the blocks. B1, B2. So here what happened is B1 will be stored here. One block is stored in one node, another block is stored in another node. Okay, so in the distributed file system, whatever the data will be divided into the blocks are distributed in the cluster. The blocks are distributed in the cluster. So for suppose I want to process the data. For suppose I want to process the data here. Okay. Now whatever you want to process, count operation, so parallelly it is going to execute in the both. Okay. So here when you try to process the data, for suppose I want to do count operation. So here whatever the query will be executed parallelly in all the blocks, so that fast processing will be there, parallel processing will be there. For suppose consider your processing speed is 1 MB per second, so here it is going to take total 150 seconds to process the data. Okay. So in the distributed file system, file data will be divided into blocks. The blocks are distributed in the cluster. Okay. Now here what happened, guys, these traditional databases also having the distributed file system. So traditional databases also having a distributed processing, but here there is a limitation in the block size. It is in terms of kbs only. It is in terms of kbs only. If you coming to the cloud, so here for suppose the same thing, if you coming to the cloud, Hadoop or ADLS, okay, in ADLS file systems or any, here what happened is the block size is 128 MB. 128 MB. So at a time, for suppose if you are raise a request, at a time it is going to fetch 128 MB of data to you. Okay, so huge amount of data. If you go for very small amount of data, you can go for traditional. If you have a huge amount of data, so we can go for this one. Okay, at a time 128 MB of data it is going to process. So that is a limitation in the traditional databases. Storage related number of nodes, processing related block size. So there is a limitation in the traditional databases which is overcome by the Hadoop. So here the challenges of big data overcome by, so here so big data challenges are overcome by Hadoop and cloud environments. Okay, so one challenge is storage related, right? So here storage related. Okay, now here storage related, we are having a, in Hadoop we have a HDFS, Hadoop distributed file system. In the Azure we are having a ADLS, Azure Data Lake Storage. Processing related, both we are having a Spark engine. Both we have a Spark engine. Guys, here what happened is this Hadoop is completely manual setup. Completely manual setup. Okay, traditionally people are using, but now everybody using in the cloud environment. So people are not using much Hadoop, guys. So the same thing as it is we can do in the cloud environment. In the cloud environment. Okay. Now here, now next we have to discuss, so how these are all overcome. Now here what happened is, let me tell you. Okay, guys, here we are having a storage related and processing related. Okay, so this one, as I said, one is Hadoop, another one is a cloud environment Azure. Similar way we are having a one more thing is a Databricks. One more thing is a Databricks. Okay, guys, for suppose if you want to use the RDBMS systems, database management systems, you can go for Oracle, you can go for SQL Server, you can go for a DB2. Like multiple options are there, everybody is going to store the data. Consider mobile networks. So we have a Airtel, okay, we have a Idea, okay, we have a Vodafone, like multiple, we have a Geo. So everywhere we can do calling and all, everybody is having their own pricing and all. Similar way here also. Similar way here also. So here we are having HDFS, Hadoop distributed file system. So here we are having Azure storage accounts, ADLS, and here we are having a DBFS, Databricks file system. So everywhere we are having a Spark engine. We are having a Spark engine. Okay, Spark engine. So here what happened, guys? Okay, now in the cloud environment, okay, so here manually we set up, okay, so the same thing whatever we have done in the big data, here the same thing we can do in the cloud environments also. So here what happened, guys? Sorry, I am having a cloud environment Azure. So here I am having a storage account. Okay, so one of the service is a storage account. Storage account. So there are different types of storage account. One of the type is ADLS. One of the type is ADLS. So here this is a data lake. If you observe that ADLS, Azure Data Lake Storage. Last class I told you a data lake is a distributed file system. So just now I told you, right, horizontal scaling. Okay, so here in the Hadoop manually we have to connect. Okay, in the Hadoop manually we have to connect to multiple nodes. Okay, and we have to set up the environment manually. But the same thing here we can do the cloud environment ADLS. Okay, so if you remember, guys, you can see some data centers. You heard this terminology data centers. So in your nearby also region level we have a data centers where the data will be distributed between the nodes. Okay, so this is already they developed. Now for suppose if you have a data, okay, if you want to insert a data, directly you can use the Azure and we can use the storage account, and whatever the data you can keep it here. Backend it is going to take the distributed file system handling everything, it is going to take the backend. Okay, but for you we can store the data in the file system. So here we can store the big data, huge amount of data also it can store. A backend it is going to maintain, you no need to worry at all. Okay, so that is the storage related. So this is one of the service. Actually, guys, now this is one thing. Here similar way, consider Databricks. Consider Databricks. Okay, so Databricks, here also we are having a file system. Here also we are having a file system which is a DBFS, a Databricks file system, a DBFS. So here to process the data we are having a Spark engine. We are having a Spark engine. Guys, this Databricks is a third party one. Okay, now so whatever the Databricks, the same Databricks, here we can handle the big data. Okay, the same Databricks it is available as a service in the cloud. So the same Databricks it is available as a service in the cloud. Okay, so the same Databricks. So if you go for only Databricks, you can maintain the data here and you can process the Spark engine, we can process the data. Okay, now using the same processing engine Spark, it can process its data or we can process this data also. Okay, so here, guys, before that let me tell you a basic terminology. If you go for any RDBMS systems, so we have a tables. Okay, guys, a tables looks like a table. Backend in the hard disk the data will be in the form of files. On top of the file we are going to create a data. Okay, to process the data I am having a SQL engine. I am having a SQL engine. So here I can process the data. Okay, so for this you have to submit a queries. So here you are going to write a queries. One second, guys. So here you are going to interact with the SQL engine in terms of language. To communicate with, I required a language. So I am using a SQL language. I am using the SQL commands. Using these commands, okay, I'm going to interact with the SQL engine, which is executed on top of the tables. Backend, the data is in terms of files only. So it is going to process the data. It is going to retrieve the results. Similar way here, what happened is I am having a file systems. I am having a file system. The data is in the form of files. Okay, the data is in the form of files. Here I am having a Spark engine. I am having a Spark engine. Okay, so here, so I can use the Spark engine. Okay, so here I can use the Spark engine. I can process the data. So Spark engine is going to process the data. So the data can be anything. It can be a Databricks file system data, or it can be ADLS data. So this is Spark engine. If you need files, okay, it is going to process. So whatever you want to request in the Spark engine, we have to provide in terms of RDDs or data frames. Okay, so next classes I will tell you. So we have to interact with the SQL engine. So here on top of the files, it is going to process and it is going to give the result. Okay, now consider for the time being, Spark is a processing engine. So like SQL engine, we have a Spark engine. So this Spark engine, it is going to process the data. It required a file. It can be this file or it can be this file. Whatever it is going to process. Simple example. One more thing. Consider I am having a village. I am having a village too. Okay. So here I am having a river. Between the village, I am having a river. So to cross the river, okay, I am using the boat. I am using the boat. So here the people will enter into the boat. It is going to cross the river and they can go out. Okay. So throughout a river, a boat is there. It is going to help. Boat is there. So I am repeating, I am having a village. Between the village, I am having a river. I want to cross the river, so I can use the boat. So I can enter into the boat, cross the river, and I can get out, go out. Similar way here, what happened is, consider here, I am having a source. Okay, I am having a target or whatever. Okay, so here I am having a file system. So here I am having a file system or tables, whatever. Okay, whatever. So here there is a Spark engine. There is a Spark engine. Okay. Whatever the data you ingested into the Spark engine, it is going to process the data and it is going to return. So just a Spark is a engine. Okay. So whatever you provided, it is going to handle that one and it is going to give the results. Okay. So this Spark engine is available in the Databricks. Okay. So here guys, what happened is ADLS, huge amount of data, horizontal scaling, huge amount of data, big data. So I can ingest the data into the lake. So in the real time, so somewhere people are maintaining the data platform. Okay, so they are going to use the file system ADLS. So I ingest the data into here. Now my requirement is I want to do the computation. Okay, I want to process the data. For this, I am using the Databricks provided Spark engine. So I can use this data or I can use this one also. So whatever the data it has, it is going to do computing. So here, whoever enter into the boat, it is going to transport, it can do. Similar way, whatever the file system, it is going to do computation, it is going to give the result. Spark engine is nothing but the way SQL engine work. So you are going to interact with the SQL engine, you are going to do the commands, count operation and all on top of the tables here. Similar way, I can submit here and here it is going to process the data and it is going to return the data. Okay. Guys, so what exactly Spark engine, what is internally architecture and all, next classes I will tell you. For the time being, understand like this. Okay. Now, here guys, As part of this learning, okay, so here first I am going to start with the Databricks. So here there are multiple data engineering services we are going to learn, guys. Okay, multiple data engineering services we are going to learn. As part of this one, I am going to start with a Databricks. Okay, I am going to start with the Databricks now. Okay, so far any doubts, guys? Up to here only, not others. Okay. So far clear?
Yes.
Yeah, thank you. So here my requirement is, I'm repeating in the basic terminology. Okay, I said we are having a huge amount of data. So I said we are having a huge amount of data. So big data, I am having a big data, huge amount of data somewhere I have to maintain. So but the traditional databases are not supporting this one. So we are going for a lake system, data lake. So here instead of maintaining your own environment, I can go for the cloud. One of the cloud is Azure. So there they already provided a service storage account. So there I can maintain the unlimited data here. So how to get the data here is a data factory. I can do. Now once the data is there, I want to do my computing operation. Okay, for suppose I am having a file, I want to see the number of records in the file. This is the huge amount of data. Then go for Spark engine. So this Spark is available in the Databricks. So here I can start with the Databricks. So Databricks having a Spark engine, it can process its own data or it can process others' data also. Okay. Now here, guys. So this Databricks, this is the third party one, right? Okay. So here, so this Databricks is the same Databricks is it is available. So here I said, so Databricks DBFS, and here I am having a Spark engine. Okay, guys, this Databricks is available in the Azure, in the AWS also. The same Databricks is available in the GCP also. The same Databricks is available in the GCP also. As part of our learning, we are going to learn the Databricks, how to use the Databricks in Azure. We can use in the Azure. Now, as this is the third party one, guys. So for suppose if you launch the Databricks, if you want to use the Databricks, we have to create a Azure account and then we have to go for Databricks and we can practice the Databricks or we can learn the Databricks here. I'm repeating. So Databricks is available in the different clouds, AWS, Azure, and GCP. So here, as part of our learning, Azure we are going to implement. To use this one in the Databricks, so first we have to log in into the Databricks. Okay, first log into the Azure and then launch the service. There we can handle. Here, guys, if you use the Spark engine, okay, it is a costly operation. It is a costly operation. Here, this is the multiple nodes. Okay, so here what happened is, so whatever the file system, okay, so consider here whatever the file system related. So here DBFS or ADLS, okay. As I said, horizontal scaling, right? Okay, multiple nodes are there. Multiple nodes are there. Okay, similar way. Okay, similar way. Spark engine is also having a multiple nodes. This is in the not a single mission. Multiple systems are connected here also. Okay, this is also Spark engine. So here the data will be into the Spark engine. it is going to process the data and it is going to return. So the data will be into the Spark engine. So here we can do the compute operation, it is going to return. Okay, so here the nothing but whatever the file system enter into the Spark engine. So here it is going to process the data, it is going to return the result. Okay, now here guys, in the Spark engine, here in the Spark engine, multiple nodes are required. So it is somewhat costly operation. It is somewhat costly operation. So here the same Databricks team, they released the free trial. They released the free trial for practice purpose. For practice purpose, they released the free trial. Here this is the one node. Okay, single node Spark engine. Single node Spark engine. So less amount of data we can handle here. But here in the Databricks in the real time, we are having a multi-node clusters. Okay, multi-node cluster. Now for our practice purpose, so first I am going to discuss a free trial in the Databricks. Okay, once you are clear this one, then at the end when you are explaining the project and some of the operations related, then I can go for Azure and I can use the Databricks there. Okay, I am repeating. Here in the Azure, I want to handle the big data. To handle the big data, I require a Spark engine which is there in the Databricks. So I have to start the Databricks. But Databricks is the costly operation. So what I am doing is the same thing. They provided a free trial. So here we are going to practice in the free trial. Okay, practice in the free trial. So finally, I'm going to here because some project related, some of the features are not available in the free trial. Those I will discuss in the Databricks. So here whatever the Spark related, okay, so here the thing is, so here the way you are using the SQL engine, SQL commands related DDL DML commands, so you are going to provide API, you are going to provide the commands. Similar way to interact with this one, they are having some predefined API they provided. Okay, so how to submit, right? Here you are writing a comments, so here similarly we are having RDDs data frames. Using that I can interact with the files. Okay, so as part of in the Databricks you are going to learn that one. You are going to learn that one. So here first we will start with the Databricks. Okay, in the free trial I am going to launch this one. So once you are clear here, then I will go here. The commands, everything is same only. Those who already working in the Hadoop background, guys, so those who are already working in the Hadoop background, so in the Spark you are going to interact with the file system, right? So whatever the commands you are using, the same thing. Okay, RDDs, data frames, transformations, access, everything is same only. Okay, now those who did not know Hadoop related, guys, the same thing we are going to do in the cloud as well. Okay, now I want to launch this free trial. How to launch this one? Guys, here as I said, go through the recording again, so then you will get a confidence, guys. Okay, Databricks community edition sign up. So here you can see this one, sign up now. So what is the email, guys? 1 second. So I'm having a Gmail. Okay, now here I'm going to create a Databricks community edition account. ADF 05. It is asking the verification code. You will get a verification code here. start a puzzle. Right. Wait here. 1 second, guys. Give me 1 second. Yes. I'm starting in the. Just give me 1 second. Database community edition. Just now we created, right? Check if you get a password or not. 1 second. Yes. So you will get it like this. Okay. You will get it like this. So in the community edition. Now, here you can see, guys, workspace. Yes, please make self mute. So here you can see the workspace, and here you can see the computing environment. In the computing environment, guys, we can start the Spark engine. Here we can start the Spark engine. Okay, compute. So here you can see by default one single node will be there. So here I am writing a dev cluster 001. So the Spark environment, so backend is the Scala. So this is the version. Okay. So here create a compute. Guys, in detail, Spark related next classes I will tell you. For the time being, it is a Spark, this one Spark engine, computing engine. That's it. So here it is running. Okay, which is a single node actually. So let it be running. So some processing related then environment is created. So Spark engine I'm going to launch now. So here I want to interact with this one. Okay. So let it be start. First computing we have to start, guys. Okay. Now go to workspace. Go to workspace. Here you can go to workspace. Go to users. This is the user. Right now I'm having only one user, guys. In the real time we will see multiple users. Okay. So each user is having its own environment. In this environment, create notebook. Create a notebook. Now here guys, so here in SQL using commands you are going to interact with this one, right? Similar way Spark engine, whatever here we have to do API, okay, we have to interact. This we can do in the different languages. So this we can do in the different languages. So we can go for Java, we can go for Scala, we can go for R, we can go for Python. Okay. As part of our learning, I am going with the Python. So here I can use the PySpark. I can use the PySpark. Okay. Now here you can see the environment like this. Okay. I'm repeating again. Go to here, go to workspace, go to users. So now here click notebook. When you click notebook, a notebook will be created like this. So here guys, you can see the timestamp. So here I'm going to make a name. I'm going to rename this one. Introduction to notebooks. Okay. Guys, here these notebooks can support different languages: Python, Scala, SQL, R. Okay, Java it doesn't support. In the interview, people will ask this question: what are the languages does a Databricks can support? What are the languages does a Databricks can support? You can see Python, SQL, Scala, and R. Okay. Now here I want to execute this one. Whatever the statements I have written, for suppose here I am writing a print Srinivas. So to execute this one, I need a computation environment. So here we can attach the sparking. We can attach the cluster. Just now we created, right? You can see this one. Okay. So when it is in the green, then it is started. You can go to the compute. Here it is green. It is started. Go to workspace. Go to your workspace. First thing is we have to attach the node cluster here. Okay. Now I'm writing. So here guys, this one we can call it as a cell. Okay, those who already having a Python knowledge, there is a Jupyter notebooks. The same thing here also. We can call it as a Databricks notebooks. Databricks notebook. Okay. Here, this one we can call it as a cell. So here I can write a statement. Print. Okay. Welcome to PVR Cloud Tech. Okay. Now I want to execute this one. To execute this one, here you can see this is one thing we can see. Here you can see a run cell. Here you can see the cell is executed. Now I want to start, I want to write a one more. Okay, you can mouse just to move the mouse to here, you can see code, you can click one more thing. Okay, now print. This is Srinivas. Now I can write a multiple statements also. Okay, Srinivas is from Hyderabad. I can write a multiple statements also. To execute this one, I said we can use this statement run cell. Okay, multiple statements also we can use. And also if you declare in one cell, I can use this one in another cell also. Okay guys, here some people are already having a knowledge, some people are entire different background, so from the basic I have to say, so I'm explaining this one guys. Now consider I'm having a equal to 10, b equal to 20, print a plus b. Now so to execute this one, you can see here I'm going to create one more cell, c equal to 50, print a plus c, print a plus c. So here once you declare a variable, throughout the notebook I can use. So this notebook value I'm going to use in another cell. Now observe this one, 60. Okay, so to execute this one guys, one way is we can use this one. Okay, another way is we can use the control enter. Okay, Observe this one. Print line 1, print line 2. To execute this one way is we can use this. Another way is we can use a control plus enter. In your laptop keyboard, you can see control plus enter. You can execute this one. You can see the result. If you observe, the cursor will be in the same cell. After executing, the cursor will be in the same cell. To do that, I said we can use the control plus enter. Okay. Now, observe this one. I am having a one more cell. So here, if I am executing using control plus shift plus enter shortcut. So here, after executing this well, whatever the controller will be moved to the next cell. Observe this one. Control shift enter. Sorry. Shift enter. Sorry. Shift enter. So the controller will be moved to the next cell. Next cell. So here the controller will be in the same cell. Okay, it will be moved to the next cell. Now observe here, print line 1, line 2, line 3, line 4. I want to execute a portion of the cells. So which are all you want to execute? Highlighted those things, and you can use control shift to enter. Only those portion it will execute. Only those portion it will execute. Okay. So here control plus shift fill. Okay, only highlighted part. Only highlighted part will be executed. Okay. Now here my requirement is, from this one I want to connect it to the file system. So to interact with the file system, okay, for suppose here in the working people, you know Unix. So to interact with the Unix file system, okay, 1 second. So consider Unix or Linux file systems. Okay, this is the file system. So here to interact with the file system, you are writing a commands. Okay, so here we are writing cp command, move command, ls command, okay, grep command. So to interact with the file system, we are going to use the commands. Similar way here also, from this one, I want to interact with the file system, I also use the commands. So here also, I want to interact with the file system. So here I am having a notebook. Okay, so to process the file in the notebook, I have to interact with the notebook. Here also we are having a commands. Okay, file system related commands. So what are the commands? Next class I will tell you. Okay, so make sure today create a Databricks account like this, guys, and share me the screenshot of this one. Okay, just share me the screenshot of this. So today assignment is create a Databricks free trial and send the screenshot. So this is my email ID, guys. You can send me the screenshot to this one And if you stuck anywhere, you can message me in WhatsApp. I can connect. Okay. Now, so this is for today, guys. So as part of today, what did we learn? One thing is huge amount of data. Traditional databases does not support the how to storage and to process. Sorry, storage and to processing or challenges of the big data. So storage related traditional databases having a limitation in the number of nodes which doesn't support. So processing related there is a limitation in the block size it doesn't support. So which is overcome by the cloud environment Azure. So as part of this Azure, so here, so this is overcome by the Azure. So here Azure is having a multiple services. Among all storage related, we are having a service storage account which is having a ADLS, a data lake which we can store the unlimited of data. So there is a one more service, Databricks, which is having a Spark engine. We can process the data using Spark. It can process its own data, or it can process the third-party file system data also, another file system data also. And here the same Databricks, it is available in the Azure, it is available in the AWS, it is available in the GCP. As part of our learning, we are going to do in the Azure. So for to use this Databricks, we have to start the Azure and we have to go to Databricks and we have to start this one. For this, it is very costly operation. So instead of that, they provided a free trial. I am using the free trial. Here we can handle the data. Okay, here we can handle the data. So here using Databricks, we can process the data. First, I will tell you in the free trial, guys. Next, I will go for here in the cloud. Okay. Any doubts, guys? Anybody?
Srinivas, Spark is the in-memory concept, no? But I mean, its cloud means a huge
Sir,
memory it will take to
sir,
process.
next classes I will tell you. Okay, so in the Spark engine, here we can have a multiple nodes. Okay, so you can increase the multiple nodes, whatever the data will be into the Spark engine. So here in the Spark engine, we can handle that one. Okay,
Okay. That in-memory is in the
in
Databricks
memory
or any
only,
Spark engine?
Spark engine only.
Oh,
Okay,
okay.
yeah.
So,
In-depth
Srinivas, what is the
architecture
difference
related.
between
Yeah, yeah.
Spark and
So,
Python?
okay. So here Python is a language. So there are multiple module. One of the module is a PySpark module. There here which is having a Spark related okay libraries we have. Spark related libraries we have, and here even here also whatever the Spark engine actually it is implemented in the Scala. So you are going to interact with this one with the Python. So it is converted into here and it is going to execute it on top of it. So this is Spark engine related. We have to provide the this one in terms of interact commands and all API. So we can go for Scala API, we can go for Java API, we can go for Python API. There we are having a PySpark is a module. So here we are going to interact with the Python. So the code you are going to write in the different language. Processing is same.
Okay, got it.
Okay, so tomorrow also you can join using the same link, guys.
And Srinivas, I tried to
Yeah.
contact, I filled the form.
This conference will now be recorded.
Yes, sir. People will contact you. So who are filling the form today, people will contact you. And one more thing, sir. Okay, so here those who joined today, you can fill the form, guys. Okay, and the community group you can join. So going forward, everything will be available. Sir, people will contact you, Satish. Okay,
Sure.
and and okay, so this one. Those who joined, you can fill the form, guys. Okay, and the community group going forward, I will provide the updates over here. Okay. Thank you, guys. Thank you.